Hello and welcome back, engineers. How are you? I hope you all are fine. So now today I'm going to explain you how you can use Xilinx ISE software for your VLSI design lab. Okay, so now let's begin. So as when you open your Xilinx ISE software, then the first interface, it will look like this, as you can see on your screen. So this is the default screen which it will appear on in front of you. So first thing which you need to do is to go to here. Now here it is written file, you can go here, you can go to new project also. Okay, or otherwise here also you have, there it is, one option. So go to file, go to new project. Okay, go to new project. Then after you give the name of the project. So I'm going to give the name of the project, just like I'm going to explain you about the first basic program, that is logic gates. So here I'm going to write down, okay, digital. Okay, I'm writing only digital. You can write down anything, no issue. So here digital. Okay, that much, nothing else. That is the name of the project, that is logic gates, digital logic gates. That is the name of the project. Okay, digital, it will be better. Okay, now that much digital. Okay, after that now you see where it is going to save. So it is home ISE digital. Okay, one more thing, here I'm using the virtual platform. So here now you can see on at the top it is written ISE 14.7 virtual machine, Oracle VM virtual box. So it means virtual box, virtual Oracle virtual machine I'm using for using this ISE 14.7, because whatever that is ISE 14.7, that is not going to run directly on Windows 10 or here, because my version it is different, as it is allowed for. So that's why, means for some version of Windows 10 it is allowed, and some for some other, because here my system it is not in that category. So that's why I cannot use directly. And I will also explain you how you can use this software on Windows 11 also. Okay, so installation process also, and what different kinds of other supporting software you will need for using this Xilinx ISE 14.7 to use in your PC. So for that you can go into the playlist section, and there you will get one VLSI lab. So there you will get how you can, what different kinds of software you need, and system configuration required for that, and how to install the software. Okay, so that I will explain. So first here I am explaining how you can use this software, and then after I will make video on that also. So any kind of question and query regarding any kind of lab related to engineering, so you can write in the comment section. So here after that, writing the name of the project, digital. Here top level source type. So here top level source type means what kind of source it should be, whether it is going to be schematic, or it means these are different kinds of sources which you can use to design the ICs. Okay, or you can use these different sources. So I am using SDL. So I will use VHDL or Verilog. So that's why SDL I am keeping this time. So VHDL language I will use to write code. So that I selected, then click next. Then here you see here product category given, then after family. So family here given means what different kinds of boards you have in your lab. So out of that you can choose any one. For example, in I have that is Spartan 3. Somewhere it is written as Spartan. Yes. So this board, no, here Spartan 3. That I have. So XC3S400 I have. XC3S400. This is the device. Okay, device name that is given XC3S400. I will make separate video on this also, means how you what different kinds of devices are there, and what families we can means family and device, and how you can use, means all kind of specification I will explain, means all different kinds of specification I will explain here. And the package type here, just like TQ 208, that is the package type of the board which I am using, means the chip that is in the lab. So that is TQ 208, and then the speed means these all things, just like what it should be, the speed, these all things you can get in the data sheet. Okay, so the data sheet of a Spartan 3. Okay, if you type in, and then I will explain how you can download the data sheet of this Spartan 3, and how you can use that data sheet for the device type XC3S400, and the package, how you can recognize that which device to use. And okay, for example, if you have the chip just like a Spartan 3, okay, then what kind of device this is. So just like you see here, many different kinds of devices are there. So which one to select? Because if you are not selecting the proper device, you package or speed or family, then the code, okay, the code which you write here, that you cannot implement on the chip. So that's why it is very important that you select these all according to the data set. If you don't do according to the data set, then it is not going to work. When you when you try to implement on the hardware, then it will not work. So next here, the speed according to the data set you can keep. And then after simulator, here simulator, there it is given ISIM VHDL Verilog. So ISIM VHDL Verilog, this simulator I'm going to use preferred language, that is given VHDL. You can use Verilog also, but since this time I'm using a VHDL, so that's why I'm keeping this as it is. So I can use Verilog also. I will explain about Verilog also. So but for now I'm using VHDL language. So this time I'm only explaining you how you can use this software, and the theoretical aspect also I will explain you later on. And then after simply click the next. When you click next, so now this is when it is the summary of your project, that is a project name, that is digital, and the project path means where it is going to save. So that is home ISE digital, so there it is going to save. Working directory, it is given home ISE digital, and description given. And now you can see device given, device family, that is Spartan 3, device yes, device name, that is given XC3S400, that package given PQ208, and speed that is given -4. Okay, so these are the description, or you can project summary. So if you want to change anything, then you can go back and then you can change. And if you feel that everything is okay, just like here, so what kind of simulator you are using. So here it is written ISIM, you see here ISIM VHDL Verilog. So ISIM simulator I'm using preferred language. Here I have used a VHDL, so that you can keep as it is. Then after there you have yes, yeah, everything is fine. So that's why we can move on to the next step. Now go to finish. So click on finish. When you, as you click on the finish, then this kind of window it will come out. Okay, then the next thing which you need to do is to click here. Now on the left hand side here, you can see wherever it is my pointer, you see just below to this design there is this one, new source. As you bring your pointer here, so it will come new source, and just below there it is written add source. So add source means if any kind of source or any kind of code you already have, so then you can click on the add source. And if you do not have, then you can click here new source. Okay, So simply I'm clicking here the new source. So click on the new source, then select the source type. So what kind of source type here? So here VHDL module. So if you are writing the code in VHDL language first, then you click on this VHDL, select this VHDL module, then select the file name just like logic gates I can write down. Okay, what I can write down? Logic gates. Okay, logic gates. Okay, done, logic gates, and this is the location where this file is going to save. So home ISE digital, this is the directory. Then click on the next. Then after here it is asking that to specify two inputs and output ports. So right now you can also define input and output ports here only, just like if I write down here anything, something like A and B, just like if I write down A and here in written it means input and output or in out. So what kind of one? Okay, if it is of single bit, this is input A, and if we do not want to select, or if you don't want to define the inputs and output ports here, then we can do in the program also, in the code also. So no issue here, I'm not defining. And next thing here is written a input or output or in out. So three kinds of leads are given. So input, it maybe you can select as input, as outputs, or in out. The same terminal can be used as input and output both. Okay, so here it is written bus means if it is only of 1 bit, then in that case no need to use this bus. But if it is of multiple bits, just like 4 bit or 8 bit, so when you use 4 bit or 8 bit, then in that case you will have to specify that this is a kind of bus. Okay, I can say many parallel connections are there, so then in that case you have to use bus, and there you have to define that what is the MSB and what is the LSB. But since here I am going to explain you only for a single bit first in the beginning, the later on I will explain for multiple bits also, but right now only for the single bit. Then you have to click next, and then after finish. Okay, okay, now then after this kind of window it will come in front of you. So here entity given, logic gates here. So these things means whatever there it is written means double dash. So this is whatever you see in the green color, that is the comment only, that is not going to affect the program. Okay, so I have already, you can delete these all, and then you can write down from the beginning whatever you get from your book or the lab manual also. So I have already saved a program in the notepad, so that I'm going to copy, and then here I will paste, and then I will show how you can use that. So yes, here on the home screen there you have okay, here ISE home, go to this one. Now here you have one folder that is named Xilinx. So this folder is shared. So later on I will explain what is this one. So this here, whatever you see on the screen now, this window, it is a little bit different because I'm using the virtual machine. So this folder Xilinx I have shared with the virtual and the physical machine. So I will explain how we can use this for sharing. Means just one folder you can share on the virtual machine with the one folder in the physical machine you can share with the virtual machine. Okay, so other than that, other than this folder, I cannot access any other folder in this physical machine. It means physical machine means in this computer I cannot access directly. I can access only this folder because when I was installing this software, then I shared this folder only. So that's why from this virtual platform I can access only this folder on the virtual on the physical platform. It means on the physical computer system. I will explain you that okay, how you can share any folder. So this Xilinx, it is present in the physical computer also and in the virtual computer. So right now I'm using virtual computer. So this folder is present. So other than this folder, I cannot use any other folder in the physical computer. So now they are next given here full adder logic gates. Yes. So here I have written. So okay, display. I will show you. So this is the program here, which Control A and Control C means I selected all and copied. Now next thing I'm going to paste in there. Now you can see at the bottom you have ISE project navigator. Click on that, and here you Control A and Control B. So whatever I copied from there, so those all things came here. Okay, I will explain. If you people want to learn about VHDL language or Verilog and any other thing regarding VLSI lab, then you can write in the comment section. I will definitely make videos on those topics also when I will get the time. Okay, and any kind of difficulty you people face, because I like to interact with engineers. So here you have, this is the program. So now whether the program is correct or not, or you can say whether the syntax is correct or not, how we can check. For checking the syntax, what you need to do is to simply, you can go here. Now in the left hand side, this section, it is process design constant given, synthesize given. So go to synthesize and check the syntax. Okay, other things, so what these all different things are there, so these things also I will explain you, but right now I'm explaining you how you can use this Xilinx software easily. So check, you can check here syntax. Here you can click, or otherwise for simulation purpose you can click here simulation. So right now I'm not implementing on the hardware, I'm simply showing you that how you can use this. So simply click on the simulation. I'm showing the simulation part only. So after clicking on this simulation, you can see there it was implementation. When you want to implement on the hardware, then this section you have to click, and then one by one you have to complete this all, then you can implement. And since I'm not implementing on the hardware right now, so that's why click on the simulation. Now then after you have to select this one. You select this. As you select this, then now you see this one is the program file. As you select this one, then ISE simulator, it will come here. Okay, at the top click on the simulator, then you have to select this logic gate, means this program file. Then after here at this place ISE simulator, it will come, and now click on this plus sign. When you click there, then two things will come. So first it is behavioral check syntax, and the second it is simulation behavior. So the first one, this behavioral check syntax, means it will check the syntax, whether the syntax is correct or not of this program, and the second it is to simulate this. So now let's go on to check behavioral check syntax. Now I'm double click here. Here it is saying that okay, do you want to save the changes you made? Yes, I want to save. Click yes. Now it is running, it means it is checking the syntax whether there is any kind of problem or not. So now here you see, here the process behavioral check syntax completed successfully. It means there is no error, everything is okay. So now then after you have to select this one, and then click on this plus, and then now you see whenever there is green tick, it means your program or the code, it is correct, no issue. Then what you can do, next thing is the simulation. So syntax you have checked, okay, your program is okay, no problem. Then now you have to simulate this. For simulation you can double click here or right click and then run. So here I'm double clicking on this. When you double click on this, then it is running simulation elaboration. Now it is simulating. Now you can see on your screen something it came. So this is the simulation part. Okay, so two inputs are there, A and B, and outputs are many, just like here. Now you see, you see 1 2, say AND out, OR out, NOT out, NAND out, or NOR out, XOR out, XNOR out. These are outputs, and A and B are only inputs. So you have to define inputs only, means you have to give values to inputs only, and on the basis of those inputs outputs will come. So for example, here you have A. So A meaning you have right click here, select A and right click, and then you go to bottom. Now you see by two way you can give inputs and outputs. Okay, so what are these two ways? First it is force constant, second it is force clock. So in case of force constant, one by one you can give inputs, and in case of force clock you can give clock inputs. You can give clock input in case of force clock, and in case of force constants, one input at a time, means one value at a time you can give. Okay, so let's first go for force clock, then later on I will explain about this force constant also. So first go to force clock. As you click a force clock, now here it is leading edge. Here now you see leading edge written, trailing edge written, starting time, offset time. So what you need, any one edge you have to use. So for example, I'm using leading edge only for this. So trailing edge I'm not using, so I am going to keep that as it is, no change. Then after duty cycle 50%, okay, no issue. Period. So period, it is very important. So in both cases, for both inputs A and B, I will use force clock. So that's why one I will keep means the time period I will keep different for these two inputs, so that I can differentiate that which one is input A and which one is input B. Okay, so as you can see, period given so first here I'm keeping this one 10. Okay, for A I'm keeping the time period as 10, and for B I will keep that as 5. So apply trailing, okay, trailing is I have to keep 0. Okay, trailing is I'm not using, so no need to change. Then apply, and then after okay. So one input I defined, then click on B, means select B, right click, and then after force clock, then after leading edge I'm using, so leading edge should be 1. So you can use trailing edge also, but I'm using leading edge only. Now trailing edge 0. Now time period here 5. Earlier I had taken 10, and this time I'm taking 5, so that I can differentiate in between A and B inputs. Okay, then click apply, and then okay, done. So these two inputs I have given. So now this next thing is that I have to run this simulation. For running this simulation, now here at this place you can say run for the time specified on the toolbar. So where you have to click run for the time specified on the toolbar here. So 1.00 microsecond written, to the left of that there it is written run for the time specified on the toolbar. If you click on that, so simply click there. So now there you have. So according to inputs you will get the output. Now simulation it is going on, so that much. So now you can see according to inputs A and B you have outputs. So how you can see, means how you can differentiate these all outputs in a better way, just like here. Okay, next thing what you need to, here you can see written zoom to full view. What is written? Zoom to full view. So you have to click on this zoom to full view. As you click on zoom to full view, then after here it is zoom in. So now next what you have to do, you have to zoom in. You have to zoom in. Click until you get a clear picture. Okay, now here you have. So what you are getting, this is the simulation part. Now you see, so wherever I click now, click mouse, so at that particular time, so whatever it is the input combination, according to that you will get the output. For example, input A and B, input A is 1 and input B is 0. So that here you can see here A is high and B is low, so that's why here 1 and 0. On the basis of those two input combination 1 0 outputs, means AND gate here it is 0. Okay, so that's why AND gate here it is 0, OR gate 1, NOT gate 0, here NAND gate 1, NOR gate 0, XOR gate 1, XNOR gate 0. So now you can see XNOR gate 0, so that's why here you see it is low, and the XOR gate there it is 1, so that's why this one it is high. And when now here XNOR gate it is NOR gate, NOR out it is 0, so that's why here this one it is low. So in the same way, wherever you click now, so this yellow vertical line it will go there, and at that particular moment of time, just like here if I click at this particular point, so now you can see input combination it is 0 0, because here both low, so that's why here you see A0 B0. So according to A0 and B0 you get the output. Okay, so when A0 B0, then in that case AND out it is 0. So A AND out 0 means here you can see this one AND out 0, then after OR out 0, then after NOT out it is 1, then after NAND out it is 1, then after NOR out it is 1, then XOR out it is 0, but XNOR it is 1. So that combination you got. So this is the way how you can use this software. Okay, this is the one way by which you can give input, just like by using force clock. By using force clock I used, means clock inputs I gave, and according to that I got the output. The second way is to give force constant. Okay, second way is to give force constant. Okay, now I'm crossing this one, so that in the second case I can explain you. Done. The simulation window, do you want to exit the application? Yes. Okay, simulation window I closed. Now again I am going to run this simulation behavior. Now when you click, then again that it will come. Now this time I am going to use force constant. So right click on this A, go to force constant, and then here force to value 1. So first two inputs are there, so 4 possible combinations are there, just like 0 0, 0 1, 1 0, 1 1. So first force combination, there it is force to value. First I'm keeping 0 and apply. Okay, okay, and then B also 0, force constant, then 0, apply. Okay, okay, so 2 done. Next thing what you need to do is to run for the time specified on the toolbar. Okay, as you click here, so now you can see here this one 0, so 0 0 you got, so according to that you are getting output here, just like when 0 0, then this one NOT is 1, NAND is 1, NOR is 1, XOR is 0, XNOR is 1. Okay, now the second combination it is 0 1. So first one A I have to give as force constant, that is 0 I have to give 0, then apply, and then OK, and then B I have to give 1. Second combination it is 0 1 now, so that's why force constant, that is 0 1 1, apply. Okay, done. Then what you have to do, you have to click here, run for the time specified on the toolbar. As you click there, so then you got the second combination. Second combination means according to 0 1 input, different outputs you can get here. Okay, different outputs, just like when 0 1, then AND output it is 0, OR output it is 1, NOT output it is 1, so that kind of thing. In the same way, third combination it is 1 0. Third combination it is 1 0. So A I'm keeping as 1, apply, okay, and right click on B, and then after force constant, that is 0 0, apply, okay. This one is the third combination. Then after you click here, run for the specified time period, then click here. So this is the third combination. According to 1 0 combination, these are the outputs you can see. In the end I will explain how you can get the all combination in the one output. Okay, the fourth combination, it is 1 1. So right click on A, go to force constant, then after you have here 1, apply, okay. Then B, here right click, and then go to force constant, then again here 1, click 1, apply, okay. Then after giving 1 1 input, right now it is not changed. Now here it is the previous value 1 0, not 1 1, because until I click here, run for the specified time period, this one it is not going to change. As I click here, this 1 0 it will change to 1 1. So when I click here, run, now you can see here it came 1 1 input. So according to this 1 1 input, A and B outputs you get according to that. After giving all these 4 combinations, what you can do, you can right click here in this output waveform window. So right click here, as you click right here, so then after here here it is written to full view. What is written there? To full view. As you click, you have to click there to full view. When you click to full view, then you get the output. So here different combinations, just like 4 combinations were there, 0 0. Now you see 0 0. Now here it is 0 0. So that's why here 0 0. According to 0 0, what different outputs are there, you can see. When you click here, so now you can see 0 1 0 1. So then this vertical line, it shows that where what is the value. So that's why if I click here, then inputs are 0 1. Then third combination, it is here 1 0. So 1 0. Then the last combination, it is 1 1. And now the first one, this one it is undefined. Okay, this one it is undefined, and 4 combinations I gave, just like this 1 2 3 and 4. Okay, it means from 1 nanosecond to this one 1000 nanosecond to 5000 nanosecond. Here it is. Here it is given time in nanosecond. So this is the way how you can use Xilinx software for performing the experiment of VLSI lab. So I will make other videos also on different topics or different codes also. I will make videos. So any kind of doubt and difficulty, please write in the comment section, so that please like and subscribe, so that I can reach to maximum number of engineering students and professionals. Because when you like and subscribe, then YouTube show my content to more number of people. Okay, so please like and subscribe, so other people can also get benefit from my videos. So thank you all. So continue, and we will meet again in the another video. Thank you.